Hello everyone. In today's project, I will demonstrate an AI financial advisor application that combines machine learning, FinTech, Streamlit, and Google's Gemini AI. The objective of this project is to classify investors based on their financial characteristics and generate personalized portfolio allocations while providing AI generated explanations. Let's begin by looking at the problem we are trying to solve. Many retail investors struggle with understanding their risk tolerance and building diversified investment portfolios. Often investors either take too much risk or remain overly conservative because they lack access to personalized guidance. This project explores how machine learning can assist users by automatically profiling investors and generating educational portfolio recommendations. The main objectives of this project are to first classify investors into a conservative, balanced, or aggressive profiles. Secondly, to generate diversified portfolio allocations across multiple asset classes. Third, to provide portfolio growth projections based on user inputs. Fourth, using a large language model to explain recommendations in plain English. Finally, deploying the entire solution as a public web application using Streamlit Cloud. Since obtaining the real investor data is difficult due to privacy concerns, I have created a synthetic dataset containing 10,000 investor records. The dataset includes variables such as age, salary, monthly expenses, savings, debt, number of dependents, investment horizon, risk score. I have also engineered additional financial indicators to improve the model performance. Feature engineering plays an important role in this project. I have created three additional financial indicators: savings rate, which measures the proportion of income saved; emergency fund months, which estimates how many months of expenses are covered by current savings; debt to income ratio, a common metric used in financial risk assessment. These derived features provide richer information to the machine learning models. Instead of relying on a single model, I have implemented an ensemble learning approach. The ensemble combines random forest, gradient boosting, XGBoost. The final prediction is generated using a weighted soft voting technique. This approach generally provides better performance and robustness than individual models. I have evaluated each model separately. Random forest achieved approximately 92.75% accuracy. Gradient boosting have achieved around 96.95% accuracy. XGBoost has achieved approximately 97.25% accuracy. The weighted ensemble produced the best result with approximately 97.3% accuracy. Therefore, the ensemble model was selected for deployment. The project was developed entirely using Python programming language. For data processing, I have used Pandas and NumPy libraries. For machine learning, I have used scikit-learn and XGBoost libraries. For interactive visualizations, I have used Plotly. The web application was developed using Streamlit. Finally, Google Gemini was integrated to generate natural language AI explanations. This is the main dashboard of the application. Users enter their financial information through the sidebar. After clicking Generate Recommendation, the model predicts an investor profile. In this example, the investor is classified as aggressive. The dashboard also displays savings rate, emergency fund coverage, debt to income ratio, projected portfolio value. Additionally, a risk coach visualizes the investor's risk score. After profiling the investor, the application generates a diversified portfolio allocation. This portfolio includes global equities, government bonds, corporate bonds, REITs, commodities, gold, cash, and cryptocurrency. The allocation is visualized using a pie chart, making it easy to understand how the portfolio is distributed across asset classes. The application also provides example investment instruments for educational purposes. One of the most interesting features of this project is the integration of Google's Gemini AI. Instead of simply displaying a prediction, Gemini explains why the investor received a specific profile, what the portfolio allocation means, potential risks associated with the portfolio, and important educational disclaimers. This makes the system more transparent and user friendly. So there is an important educational disclaimer so that this application is based only for educational purposes and no commercial purposes. The complete project was deployed using GitHub and Streamlit Community Cloud. The source code is publicly available through GitHub. The Streamlit deployment allows anyone to access and interact with the application directly through the web browser. The link to the Streamlit web application is also provided at the description. The Gemini API credentials are also used and securely managed. Um, so let's give a demo to our application that has been deployed live using Streamlit. As you can see, this is our application. This is a Streamlit application. This is the AI Financial Advisor, our application. And as you can see, this at the left, this is the slider for the inputs like annual salary, monthly expense, current savings, total debt, dependence, risk score, horizon years and all those things. And you can just click generate recommendation to generate a recommendation on this, and it will generate the recommendations like investor profile. This is the aggressive showing for this current inputs, then savings rate, debt to emergency fund, and then the risk score is there. Why this recommendation was generated is also given. And then, as you can see, the portfolio allocation is there. Portfolio allocation, these are the example instruments of each asset classes. So this is the amount asset classes portfolio allocation. And then this is the portfolio projection, and this is the example instrument of each asset classes. Then let's click on AI explanation. See, it says welcome the Gemini AI explanation. So it provides an AI explanation using Gemini to kind of explain why what should do, what the user should do. So why the profile was selected, and then what the allocation means for the user, uh, then the any precautions the user should take, and then also an educational disclaimer. This disclaimer is also given in the last final tab, which is educational disclaimer. This app is for educational and demonstration purposes only. It does not provide regulated financial advice, investment advice, or product recommendation. So now let's go back to our PowerPoint presentation. So about future improvements, there are several opportunities for future development. For example, integrating real-time market data, applying portfolio optimization techniques such as modern portfolio theory, adding shape explainability for machine learning transparency, implementing ETF screening and investment research features, and building a retrieval augmented generation system for advanced financial question answering. My name is Devodip Chaudhary. I am a professional data science and machine learning expert based in London. I hold a master's degree in financial technology with data science from University of Bristol. I also have a background in computer science and a strong interest in machine learning, artificial intelligence, data science, and financial technology. Through my YouTube channel, I share practical projects and tutorials focused on data science, machine learning, and AI applications. So, thank you for watching this uh, video. If you found this project interesting, please consider liking the video, subscribing to Infometrics Labs, and following my future work. You can also explore the source code on GitHub and try the live application yourself. Thank you, and I will see you in the next project.